Okay, I'm continuing to experiment with the intent of showing that this Fluke 8842A multimeter that I purchased on eBay is relatively inexpensive, but the EEV blog suggested years ago that it's a great unit in terms of value and accuracy. And since I have not had the unit calibrated, I just want to verify that the accuracy of various features and functions is still good. And so far, the experiments are proving that it is good. It's accurate and precise. This experiment is to experiment on the AC RMS board, which is an additional board inside of this Fluke meter, to see how well it measures AC RMS noise. So what I've got set up here is I'm using my Digilent Electronics Explorer board along with Waveform software to set up a waveform with offset with 1 volt and has a sinusoidal noise signal of 100 millivolts amplitude. I'm feeding that into scope channel 2. That's the blue signal you're seeing. I'll set the trigger so it stops moving. And then I'm feeding that into an inverting opamp here on this breadboard. The beauty of an inverting op-amp is you can actually attenuate the signal. So that's what I intend to do, is attenuate the signal. I'm taking the output of that attenuated signal, that's the red or pink signal you're seeing there in channel 3. So the Waveform software, the Digilent Electronics Explorer board, is seeing that output, measuring the AC RMS at, for example, 43 millivolts right now for the attenuated signal. Same thing as we're seeing on the Fluke. But I want to take that down to single-digit levels. So I'm going to attenuate that using this op-amp and just modifying this variable pot or resistor. And since it's an inverted signal, as you can see by the waveform shape is inverted, right? That means that its offset is actually negative. So as I turn this thing down, it's going to rise in this plot as it drives towards the 0-volt level. I'm just driving down the whole signal by attenuating through this op-amp. Now we're down to 10 millivolts over here. Same signal as seen over here on the Fluke. In other words, the same volts AC RMS. We're reading about 9 to 10 millivolts AC. Same thing over here, 9.5 to 10. And I'm going to crank it down some more, driving it all the way to as low as it'll go. We're seeing 1.7 millivolts over here, about 1.8 or 9 over here. The difference is that I think that the Fluke meter is integrating more data. And so if I change the scale here, go the other way. Now these numbers are matching 1.6 millivolts. I'll drive it down further if I can. There's a certain level where the Electronics Explorer board background noise it can't be driven any lower. There's 1.3. Yeah, that's about as low as you can go, I'm afraid. So the good news is the Fluke multimeter is accurately and precisely reading the volts AC RMS. This experiment took it all the way to the single-digit millivolt levels of noise. So I'm satisfied with that. We can't go much lower. I'd love to do microvolts, but I don't have any equipment that can generate noise levels, without just background noise that washes away that signal. So that's it for this experiment. So far, this Fluke 8842A multimeter is performing extremely well. It's accurate and it's precise. Thanks for watching.